Hello, and today, today I'm going to show to you the shape of molecule. We have uh, some of shape of the molecule. For example, I'm going to show you the definitions of bond pair of electron and lone pair of electron. For example, I have a molecule of water, right? So this molecule of water contains of hydrogen and oxygen. All right, so if you see periodic table, oxygen is in group 6, so there will be 1, 2, 3, 4, 5, 6 of oxygen, and then we have one hydrogen and the other one of hydrogen. Okay, so for hydrogen, I use different color, so I just use cross, and then as you know that hydrogen is stable when they share two electrons, and then oxygen will be shared after you have two additional of oxygen, two additional of hydrogen, so you'll have H2O. All right, and then the shape of the molecule for H2O is actually V shape or band. Okay, because you have basically you have two bond pairs. For the next time, I'll just use BP, and then you have also two lone pairs, which is LP. Okay, so remember that if you have two bond pair and two lone pairs, then you have a V-shaped molecule, and the bond angle is actually 104.5 degree. Okay, so that's the first one. The second one is actually, for example, if I have a molecule of ammonia, for example, ammonia is actually NH3. All right, if you see the periodic table, nitrogen is in group 5, so there'll be 1, 2, 3, 4, 5 of nitrogen. And then I'll just use hydrogen is actually 3, so I just use cross, cross, cross. Therefore, I have 1, 2, 3, and of course, you have a nitrogen. Okay, so excuse me. So basically, you have this one of nitrogen. Okay, so you have 8 already. This one is already 8. Okay, so the reason why I draw in specific shapes meaning that there will be like repulsion between this lone pair and bond pair. All right, so then I will have like this shape. All right, now it's obvious that I have 3 BP, 3 bond pairs, so this is actually 1. Okay, so 1, 2, 3 bond pairs. Okay, 3 bond pairs. And then I also have only one lone pair. One lone pair is actually this one. All right, so because we know that the repulsions between the lone pair and bond pair is less than repulsion between lone pair and lone pair. Therefore, the shape of this molecule will be trigonal pyramidal. The trigonal pyramidal has 107-degree bond angle. All right. Again, so you have 3 bond pairs and 1 lone pair, and then because the repulsions between bond pair and lone pair is less than repulsions between lone pair, lone pair and lone pair, then you have a trigonal pyramidal of 107. Next example is actually we have a CH4, for example. CH4 is actually methane. 1, 2, 3, 4. Why 4? Because carbon is in group 4. And then you have a hydrogen. 1, 2, 3, 4 hydrogen. And then you have 1, 2, 3, 4. And then you have this one, 8. Okay, so CH4. So here you don't have a lone pair of electron in the central atom of carbon. Therefore, I just write 4 lone pairs with no lone pair. All right. So it makes the shape of this molecule is actually tetrahedral shape with 109.5 degree. All right. So again, the shape of this molecule is actually tetrahedral with the bond angle 109.5. All right. How about we have a, for example, we have a molecule of BH3. So let me write here BH3. So B is in group 3, so there will be 1, 2, 3 of valence electron of boron. And then I also have 3 hydrogens, so 1, 2, and 3. Okay, so I have a 1, 2, 3, and then here I have a 6. All right, so I have a 3 bond pairs, but no lone pair. So the shape for this molecule is actually trigonal planar, because you don't have a lone pair of electron, and the shape of this molecule, I mean the bond angle for this molecule is 120. All right, so the other one is actually we have a shape of PCl5, for example. I have a molecule of PCl5. So it's actually 1, 2, 3, 4, 5, and then I have Cl, Cl, Cl. Sorry, sorry. So I have a PCl5, then I'll have a P, 1, 2, 3, 4, 5. So Cl, 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 Cl. And then I'll just use this one as a dot, 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 dot. And then instead of writing like this one, okay, so I just use, it's actually like this one. All right. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. If you're confused with these lines is actually the lone pair of electrons. So for example, you have a 1, 2, 3, 4, 5, 6. So there will be 3 lines. So it will be equal to Cl like this. Okay, so don't get confused. So here in this molecule, we have how many electron in the central atom of phosphorus? There will be 10. Okay, there will be 10 electrons in the central atom of phosphorus. Then, therefore, you have a trigonal bipyramidal shape, and there will be 2 bond angle, which is 120 and 90 degree. Okay, all right. And then lastly, I have, for example, of SCl6, for example. All right, so 1, 2, 3, 4, 5, 6. Then I have Cl, 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 and Cl. All right, so I'll just use this one as a, like the previous one. I have this. Okay. All right, so in this case, I have a 12 electrons in the central atom of sulfur. Okay, I have 12 electrons in the atom of sulfur. So therefore, the shape of this molecule is actually octahedral. All right, and the bond angle is actually 90 degrees Celsius, 90 degrees. All right, so I hope you learned something from this example of shape of this molecule. All right, and then I hope you also learn that we have several example of shape of the molecule. So you just see that we have variations of shape of molecule. All right. Thank you for watching, and I hope you subscribe and like. Thank you.